In this video, I'm going to show you how to use the TR55 Small Watershed Hydrology Program by the NRCS and USDA. Now, we have our example over here, and it's determining runoff from a single sub-area for existing and developed conditions and sizing a detention basin. Over here, we've got the TR55 welcome screen. So I'm going to show you a little bit about this as I go through the example. And then on this side, we actually have the TR55 manual. And I'm going to keep this open as a reference, but I'm also going to show you the reference manual that goes with the TR55 program. So I'm going to go ahead and click on Start. Once you get used to it, you can skip this introduction. If you're a new user, you can click on New User, and you can get help for any of the information that we have. You can also get a TR55 user guide, which pops up digitally like this, and it's got the information that I'll go over as our example, as part of our example. Now, I'm going to go ahead and close that out, and I'm going to click on Start. So the first thing that I want to show you is the TR55 user guide. The example is actually in the user guide also, so I'm just going to go ahead and scroll this to the top and kind of explain what we're looking at. In the user interface, you have a file command, save, new, open. These are our typical. And then you have options. Options allows me to either select an English or metric. So if I was in English units, which I am now, I have acres or square miles. Now the project data is information like land use. Is it agricultural, rural, our time of concentration, how long it takes a little drop of water to get to our outlet. Structured data we haven't really looked at yet. Structured data has to do with the ponding in itself, the actual structure for the detention basin. Project data also has reach information, reach data. That means there's a stream or a pipe or something that is carrying the flow. Now the other thing that I want to show you is these project data also entails these icons here. So you can either use buttons for land use, and notice that we have our curve number and our different types of land use. If it's urban, developing urban, cultivated agricultural, are different options of our land use details. These same buttons are the same as if you selected the tabs up here. Okay, so just be aware of that. Also, global data means the storm. Notice in our first window, we have the state that we're in or wherever our project's located and the county. So our global data has to do with our storm data. And we can select what type of storm data that we're using. So we can pull this down and say, okay, it's a type 2 storm, type 1, type 3. Here in Florida, we're typically type 2, our different rainfall periods, and then our 24-hour inch rainfall based on our storm event. That's where we get our NOAA maps. And then you also have custom rainfall distribution. You can actually type in the S-curve type that you need, or you can create a dimensionless unit hydrograph. We're going to stick with the storm data as it populates itself. Okay, now the last one's run. It's not highlighted. It's this little red X looking thing that runs the program, and we select the storm event that we're running. Okay, so we can pick the design storms in comparison. Now, in the example that we have, I highlighted it so that it says, okay, in the light yellow, it says an industrial development is planned on 12.5 acre site in Franklin County, Missouri. Okay, so that's planned. That is our post-development. And then in the baby blue, it says the land is presently being used for corn production and is planted in straight rows. Basically, it just told us it's an agricultural land use, and there's no conservation practices, and the vegetative cover is good. Now, the other thing that I didn't highlight, notice that the soils, the hydrologic soil group is B, so it drains pretty good. The other thing that I noted is here in the orange, it says there is no defined channel running through the property, but there is evidence of sheet flow and shallow concentrated flow. The sheet flow path has been determined to be 25 feet long at a slope of 0.8%. The shallow concentrated flow has been determined to be 820 5 feet long and has a slope of 0.8%. So it's basically telling us the information that goes into our project. Now in this one we have a single sub-area basin. Okay, but in the program we can actually have multiple areas. So I want to show you on the user guide. We'll go through a couple of things and then we'll get to the example, because you need to be aware of what this computer program can do. It goes through what the background of the program is, so you can get some historics of how it came about. The other thing is the capabilities and limitations of the program. So in this one, the minimum area is 0.01 acres, okay? So you need to look at the results if it's less than an acre from any of the sub-basins. The maximum acre is 25 square miles. The number of sub-watersheds. We can have one watershed or we can have up to 10 watersheds, meaning there's a main drainage basin and it has little tendrils from the tributaries. Now the time of concentration for any sub, the least it can be is 0.1 hours, and it can't be any greater, or the time of concentration is up to 10 hours. There can be 10 reaches. When somebody says there's a reach, they're basically saying some type of channel, stream, river, something that's sending water from one point to the other. Reach routing, types of reaches, channels or structures. So a reach can also be like a box culvert, or let's say not a box culvert, but like a control structure in a detention pond. So if you live in an area that has a stormwater management pond, then likely it has a control structure of some type, especially if it's a detention pond. The reach routing, there is a method, Muskingum-Conge routing methodology we'll talk about later in the course. The structure, routing, storage indication. The structure types, there's pipes and weirs. There's also orifices that we'll be looking into later. There's 3 possible trials for your structures. Now this is one of the limitations, is that if your project has more than one structure in it, then you need to use TR20, which is a more powerful version of the TR55. TR55 is just something small, used on a small basin, whereas the TR20, Technical Review Paper 20, has more of the capabilities. So it also has rainfall depths, either default or user defined, 0 to 50 inches, and rainfall distributions. These are the ones that we've been going over in our lectures, type 1, 1A, 2, and 3. We also have other ones. Now, the different states have contributed, looking back into our program, different states have contributed different rainfall distributions. So we can pick a county, and then we can pick a state, and then we can pick a county, and we're in Osceola, depending on if we're in east, west, or is a municipality that the MSE is the different areas that actually maintain the storm systems. So we can also, going back here, we could also do a dimensionless unit hydrograph. And remember, our antecedent moisture condition is 2. That means we're assuming that the rainfall, that it hasn't had back-to-back rainfalls. Okay, so that gives you a little bit of the capabilities that this program has. Now, the other thing that I want you to be aware of is there is minimum data requirements. We have to put in the user, the state, the project, and the subtitles. We have to fill this information out. And if we have a dimensionless unit hydrograph, we have to fill that out. We also have to state what source data we have. And we have to give information regarding the sub-entity, like if we have different basins. For example, see the dotted lines over here? That represents an overall watershed. And then you have areas 1, 2, 3, 4, 5, etc. Those are going to be your sub-basins. Now, here's a sub-basin, and here's the drainage divide between these two areas. Now, you also have within here the reach A, reach B, reach C, reach E. that means those are streams or some type of channels that need to be delineated. So we can build up to a small 10 basin drainage model in this. Okay, now in this one it shows an example. Area A, sub-area A up here discharges into reach A, and then reach A goes into reach C. Sub-area 2 here discharges directly into reach C. Notice it doesn't go into reach A, it flows into the upstream end of reach C. Okay, and then C goes out. So we have different reaches in which they discharge to. Right? Just be aware of that. Okay, now going on. So this is the user interface. We have talked about these buttons. I've talked about the entry box. Whether you're working in acres or square miles, and we can also, the other thing is you can directly enter information in here. So with that, I'm going to go ahead and get started on the exercise, example 1. So it goes through step by step, so you shouldn't have any problem. So the first thing is I'm going to leave user ID, and I'm going to leave it as my first initial last name. The project is going to be example 1, as it's shown here. And the sub, you always tell it, some people write EX for existing. Make sure when you're doing it, you give it a proper name people understand. Now, this one said it was in Missouri, and the county was Franklin. I started to hit an F so it can scroll down. Okay. Now, the area is going to be in acres, and it's standard. So I filled out this information as it's shown here in the example box. The next is on 2, we're talking about the rainfall data. So I can either come up here to global data and click on the storm, or I can actually click on this icon here and get the storm data. Now, we're the type 2, so it's type 2. Look at 2, 5, 10, 25, 100, 1. So now I need to change. I can click on the NRCS storm data, and it automatically updates this, or I could have typed it in. So then I hit accept, and I've got that set. Now I'll scroll down to the next page. All right. So now it says enter the sub-area name, the sub-area description, and the water level this sub-area flows into. So I click on this, and I just type in tract 1, existing land use, and I pull this down and I go outlet, because I only have one basin. So you either discharge it to a reach, if it's a project, you discharge it to a reach that you've created, or you discharge it to an outlet. Okay. Now the next part I have in step 4, it says click on the land use tab. So instead of just directly typing these 3 in, I can come up here and click on that icon here, which is my land use, or I can pull down project and type in pull down land use. It says click the land use details button at the top to open the land use details. In this, enter the sub areas in the appropriate location, and then click accept. And the first thing it said is that we were in cultivated agricultural, and it was a row crop, and they were straight row crops, but it was in good condition, and it was a soils type B. So I'm going to type in 12.5, okay? And then I'm going to, notice down here, once I click into another box, it projects the information down. So if I had another one that was 10 acres, it would actually start modifying this curve number. So if it was 10 acres here, and I'm going to delete that out, notice 78 and 78, the weighted curve number is still 78. If I said that it was 100 here, notice that the curve number gets delineated. So I'm going to go ahead and delete that off. So my curve number is going to be 78, and I'm going to click accept. Now, the next part of it, see how it highlights it in green here? The next part, what I need to do is, and notice that it updates my storm event too, is I'm going to set the time of concentration. Again, I can click this button, or I can pull it down in the data, project data, time of concentration. Now, it said that it had sheet flow of 25 feet. And if you go back to the first page, it says that it had a sheet flow of 25 feet and a slope of 0.8%. 0.8 is 0.08, okay? So make sure when you're doing this, you're typing, whoops, too far down. You're typing in the information correctly. I'm sorry, it was 0.008, 0.008. And then the Manning's Inn, if I pull this down, is cultivated with 20% residue. So if I go back up and look at the description, it said that it was corn production, straight rows, and the vegetation was good. So that's an assumption that they made, that we knew that it was cultivated land and that the residue, that was an estimation on their part. We would need to go out in the field and determine that. So I'm going to go back down. The shallow concentrated flow was 825 with 0.008, and it is unpaved. Okay, so our time of concentration gets figured up over here. We don't have any channels, so I'm going to click accept, and I'm going to move to the next step. So now everything's filled in. So I've got my pre-development. I'm going to say up here just so you get used to this. This is pre-development. Okay. So now what I'm going to do is I'm going to run this. I've got all my data in there. I'm going to click on run, or click the red little, looks like a little body running. And I said it was a 50-year storm. So, or the example said, we need to limit the peak discharge from a 50-year storm in an undeveloped condition. So we need to run that to see what that looks like. Okay. So once I've got that, I'm going to click run. It processes and it says in the outlet I have 66.81 CFS. Okay. So I've got 66.81. Now, in the next part, I'm going to go ahead and save this. I'm going to go ahead and close, and I'm going to go File, Save As, and I'm going to put it in my, I'm actually going to put it on my, where mine's defaulting here, so I'm going to leave it here. But you might want to save it where you can find it later. Example 1A. I wouldn't do 1A. I would actually call it pre-development or existing condition. Okay? So I'm going to save that. Now, the next thing is based on this. We knew that we had the 66.8 CFS. Now, if we converted that into volume, and we know that the storm event, the area of the storm, we could also figure out our acre feet of volume. Okay, so when we're looking at the file printing, we can go File Display. That's this button right here. Oops, sorry. We can go Output Definition, and we can go, okay, we want to look at the summary page. Now, our summary page isn't going to look like this one. They actually have the file display as a TR20 printed out report. But if we go ahead and look at the data that we can see, we can click on that and go Report Viewer, and we can view the information. So basically what it says is, gives us our sub-area information. Here's the TR20 reports, printed file page. So we can, I'm sorry, this is where they're getting it at. In the file display, once we view it, you can actually change the style of how it's looking. This is the information basically on the multiple TR25 or TR55 reports. So it's telling us what information we actually input and what our results were. Okay, now in the TR20 reports, you can look at the printed file page, and it's going to pull up this one here. So TR20 printed file page. And what it has is, again, it tells us what the information is, our input information, and then it has the storm event. Okay, so it's basically showing us our hydrograph. So here's our time, here's our flow, there's 10 hours, and then it goes 11 hours. And notice the peak discharge, the 6681, that what it is actually at time 1201, but we don't see 1201 here. It's going to be interpolated. So that's what this information is showing us, okay? But this would be our inflow hydrograph to the outlet. Okay? It goes all the way to 24 hours, okay, for the 50-year storm event, okay? Now, the next part of it is now we're going to have to, instead of starting with a new file, we can bring in our previous file. We can use the previous data. I'm going to go ahead and close this. We can pretend that I haven't closed it, but this thing, the assignment says we closed it, and now we're opening it back up. Now, what we will do is we'll end up changing the data that's in here. So we're going to edit it, and I'm just going to do a file save as. And I'm going to call this example, and I'm going to call it, I'm going to go ahead and just save this just in case I save. And then save as. And then I'm going to say post development. Okay, so now I can go ahead and change that and go future condition post development. And I don't have to change any of that. But I do have to change the land use now because we've changed it to a developed land. Okay, so on this one, it goes edit the user ID, the project name, and the subtitles as appropriate. Edit the area, the unit hydrograph, and the drainage if needed. So in this one, in the land use details, when I click that, I'm going to delete that, and I'm going to go to the urban area. Okay, and in the urban area, I have industrial here, so I've got to scroll down, industrial, and we're still a whole hydrologic soil group type B, and that's going to be 12.5. So I'm just going to go ahead and click accept, and notice that it changes to an 88 curve number. All right, now from here, I'm not going to change the time of concentration because it didn't give me any additional information on the time of concentration except for, it appears that now they've made the decision in this example. I'm sorry. I'm going to click on the time of concentration, and I'm going to change from cultivated, I should have realized that, cultivated to smooth surface because it's an asphalt parking lot, and we're going to assume it's going over a paved surface. The other assumption that they're using here is that the time of concentration is going to follow the path of the existing ground. That's why they're leaving it as sheet flow and shallow concentrated flow. I wouldn't say this is true. Usually when you design and you develop, all that changes. But anyway, so I'm going to go ahead and click accept. So the time of concentration's changed. Now we'll go ahead and change the name of that to, delete that, highlight it and delete it. Developed land use. Okay, just to keep everything consistent. Now we're going to run it. In the example, it said to run it with a 25-year storm event for the post. So I'm going to run this, and I'm going to check off the 25 and uncheck the 50. I'm going to run, and now we have 77. Previously, we had 66.81, so we actually have to hold some water on our project. So I'm just going to go ahead and File, Save As, and it's still post-development, so I'm just click on Save, and yes. You can put it as example 1A and 1B if you wish, it doesn't matter. I just like to use descriptive information. So I'm going to look at the data, and go ahead and do Report Viewer, and go View, and then TR55, and look at the printed page. So now what we have is, if you look at the peak, it's going to be at a time of 11:95, which is between here and here. And we have a peak of 77:54. Okay. Now, the next part is going to be the sizing of the detention basin. I'm going to go ahead and close that out. And we're gonna do the detention basin sizing on this here. All right. So now what we need to do is go ahead and look at how we want to size the detention. I'm going to pause here and start the video in the next one.